Okay, for this particular lesson, we're going to take some of the factoring examples that we've done in previous lessons and see how this could work into some different ways of working a problem. If you get a rational expression, sometimes the factoring doesn't take place evenly, so we would need to take a different look on how to divide two expressions like that. So we're going to take a look at a couple different methods through this couple videos. But let's go back and let's take a look at some things that you probably learned back in grade school. If you remember, you had something called a fact family. And you probably learned many different ways to do this, but just for instance, let's say we had 2 times 3, and we know that that equals to 6. Well, we can rewrite the 2 and the 3 and the 6 in a number of different methods, either using multiplication or division. So in this case, if I did 6 divided by 3, I would know that it's going to give me the 2. So these are what we call fact families, and so they all kind of link together through multiplication and division. Well, the same thing happens when we're dealing with polynomials to a certain degree. If you keep in mind here, let's say we had x plus 2 times x plus 2. If we were to FOIL those together, I would have x squared plus 4x plus 4. So we multiplied two expressions to come up with a third expression. So if I did it as a fact family, I could reverse that process and take the product of what we got and divide it by one of the individual factors. And if I did that properly, I should end up with the third part of the fact family. So you can see here that the x plus 2 and the x plus 2, which were being multiplied together, should give us the x squared plus 4x plus 4. Now, we could restate that problem as a rational expression. So division doesn't have to be written with the division symbol, but it can be written with the division bar, and it in essence means the same thing. And this is where we used factoring to figure this out. And so when we factored the top one, we had the x plus 2 times x plus 2, and then of course 2 of the x plus 2 expressions could cancel out, leaving us with just a singular x plus 2. So there's a number of different ways to look at this. A third way that we could look at this is through your old third grade method of long division. Now, keep in mind here, we had long division that looked like this, where 15 divided by 225, and so we could say that goes in one time, and then we would subtract that 15, and we would drop down the next term, and we would have 5 times 15 gives us 75, subtract that term, and that would leave us a remainder of 0. So you can see our fact family there, 15 and 15 and 225. Now, what we're going to find out, and what we already know, is not always do things divide evenly. So let's say, for instance, we had 15 divided by 230 divided by 15. We could do 1, and of course we would subtract that, but this time it's going to leave us 8. So I'm going to drop the 0, and this time it goes in 5 times again, but that gives me 75, so it doesn't go in even. So what happens here is I'm left with this remainder of 5. Now, in grade school you got comfortable writing it as 15 remainder of 5, but in reality the technical math way to write this would be 15 plus 5 divided by 230, because that's the remainder of what's being divided. Okay, and so we would want to get used to writing it like this, because when we get into polynomials, we're going to need to write that in a correct manner. Now, let's take a look at how long division would look with polynomials. So we have polynomial long division. So we have our x squared plus 4x plus 4 being divided by x plus 2. What we want to know is, what do I need to multiply times x plus 2 to get x squared plus 4x? Or even better yet, what do I need to multiply times the x to get x squared? And so that's where we're going to start right here with just a singular x. So if I do the distributive property, so I'm just going to basically do this, x times x plus 2. That's going to give me x squared plus 2x, which we see isn't perfectly even. The next step in long division is to subtract this. And if you recall from previous lessons, when we subtract that, of course we have to distribute that negative across there. And then we end up canceling out the x squared values. When I do 4x minus 2x, that's going to leave me 2x. And then I'm going to bring down the 4, just like I brought down the 5 over here. Again, I need to figure out what do I need to multiply times x to get a 2x. And so we're going to add 2 there. So again, we're going to be distributing 2 times x plus 2, which is going to give us the 2x plus 4. Lastly, I have to subtract those parts and distribute the negative. So that's going to leave me with a remainder of 0. And so you can see here the fact family. X plus 2 times x plus 2 gives us x squared plus 4x plus 4. So this is a completely different way of looking at rational expressions or dividing polynomials. So we can always use the polynomial long division method. Okay? Now, it's not always going to be a remainder of 0. That's when we need to know how to write our remainder as a polynomial expression or a rational expression. So let's take a look at this. This takes a little bit of practice, so if you don't get it the first couple times, don't get frustrated. It's going to take more and more practice, and you're going to have to do some problems to get comfortable with this. So it's a little awkward at first. So sample problem 1 has part A and part B. So go ahead and pause the video and use the example above as a guide to working these doing polynomial long division. Okay, let's set this up first. So we're going to start with x to the third. Excuse me. I'm going to start this with x to the third. Sorry about that. I'm just trying to give myself the right amount of space. X to the third minus x squared minus 2x plus 8. And of course I'm going to be dividing that by x plus 2. So my thought is, what can I multiply times x to give me x to the third? And of course I can multiply x times x squared. Notice I'm going to put x squared over the squared term. That's extremely important that we keep those lined up. And then I'm going to distribute x squared times x gives me x to the third. X squared times 2 gives me a positive 2x squared. Now, this is where it can get kind of complicated. I have to subtract this. So in subtracting this, I have to distribute the negative, so I give that a negative, and I'm going to change that sign to negative as well. So when I subtract these, x to the third minus x to the third, those cancel out. When I do negative x squared and negative 2x squared, that's actually going to give me negative 3x squared. And then I'll drop down the next term. Alright, my next step is to say, what do I need to multiply times x to give me negative 3x squared? And a negative 3x will accomplish that. So negative 3x times x is negative 3x squared. Notice, I want to make sure that those signs are the same right now, because when I subtract it, it's going to change it, and we want those first terms to cancel out. Negative 3x times 2 is going to give me a negative 6x. And then, like we said, we need to subtract that whole thing. So when I do that, that's going to change this to a positive, and it's going to change that to a positive when I distribute that x. Negative 3x squared and a positive 3x squared will simply cancel out, and that was the objective. And negative 2x and positive 6x is going to give me a positive 4x. And now I'll drop down the positive 8. Again, I ask myself, what can I multiply times x to get a positive 4x? It's going to give me a positive 4. 4 times x is 4x. 4 times 2 is positive 8. I'm going to subtract, so I'm going to distribute a negative, And when I do that, those all cancel out, leaving me a remainder of 0. And so you can see here that this polynomial on top of the division would actually represent our answer, x squared minus 3x plus 4. So you could have done this through rational expressions and factored the cube with grouping. That's another method to go. But that's not always going to work so comfortably, because sometimes you're going to end up with a remainder. So let's look at part B, and let's try that. We're going to have x to the third minus x squared minus 2x plus 8. Same expression as in the previous problem, but this time we're going to be dividing by x minus 1. So this is going to give us a little different look. So what do I need to multiply times x to get x to the third? And I'm going to need to do x squared and put it over the squared term. So that's going to give me x squared minus x squared, which creates kind of a strange situation here, because when I subtract that and I distribute the negative, this should be to the third, I will cancel out those x to the thirds, and I'll end up canceling out those x squareds, which means now I need to drop my negative 2x. So here's a problem though. There's nothing that I can multiply times x minus 1 that will simply give me negative 2x. So in this particular place, I'm actually going to hold this place with a 0x and bring down the 8. Now I have a binomial that I can work with. So I'm going to use negative 2 times x gives me negative 2x, and negative 2 times negative gives me a positive 2. And whenever I distribute the negative, that turns to a positive, that turns into a negative, so that cancels, and that leaves me a remainder of 6. Now, just to point this out, our answer is x squared minus 2 with a remainder of 6. I don't need to write the 0x, but let's look back up here and recall how we write a remainder. This is extremely important. So our final answer is going to be x squared, minus 2, and then I have to add the remainder back to that expression, but the remainder is being divided by the x minus 1, because that's what the whole expression was being divided by. So I had a remainder of 6 that still needs to be written as a division problem out of the entire amount. So this is our final answer in the polynomial long division. Now, this can become very confusing, and you're not going to probably understand it or get it the very first time that you do it. It's going to take a number of practice tries at it, but it gets better with time because it's pattern. It happens over and over again with a handful of variations. So same things you'll see pop up time and time again. So you need to get into the point where you're recognizing the patterns.